In this video, we will discuss about the boost converter. This is also called as a step-up chopper. It's a type of DC to DC converter where we convert some voltage from input to output, where output voltage is always more than the Vs. So output voltage DC is VO and input voltage or supply voltage is Vs. So in this case, the output voltage is always more than the supply voltage. So where we can step up the voltage, so that's why it is called step up chopper or boost converter. So now we'll see the circuit operation of the boost converter and find out the expression of voltage in boost converter. So here is one inductor will connect. Supply side is Vs and here is one switch will be connected. This switch is the high frequency switch, so we can use MOSFET or IGBT for this operation. And here is one diode and connect the load. Across load is VO. So this is the circuit diagram of boost converter. Now we have to find out the conditions when boost converter is operated on and off condition. So first we will see the condition when switch is on. So when switch is on, we can draw again this circuit and make it switch on. So we'll see the direction of current and voltage here. So when supply voltage is given to the circuit, so inductor starts to store the energy. The polarity will be positive to negative. And when switch is on, so this will work as a short circuit. Switch is short circuit and no current is flow through diode because current is getting the minimum path to flow. So diode is become now open circuit and this is the load. So in this case what will happen, this is the plus minus VO. So in this what happened, the all current is flow through this circuit, closed circuit here, no current is flow here. So now we can find out the equation of the voltage by using KVL. So here you can see the direction of current, rise of voltage, so it will be plus Vs, and is a drop in the voltage across the inductor, it will be minus VL is equal to 0. So we can get the first equation, VL is equal to Vs. And we also know that current flow through the inductor is going to start from minimum to maximum. So we know that delta I is equal to average current will be I minimum plus I maximum divided by 2, because we know that the current starts to increase in the on time and decrease in the off time. This is the I maximum, this is the I minimum. So now we'll see when switch is going to off. When switch is, next condition, when switch is off. So when switch is off, we redraw the circuit here. So inductor in off condition, this is positive negative. So inductor off condition, what happened, going to release the energy, and that path we are getting through the diode because switch is off. So all current flow through the load and inductor is release the energy through the diode. So we know the nature of the inductor is now polarity will be reverse. So here will be negative, here will be positive, and diode is going to short circuit because all the current is flow, and this switch is open, so open circuit, and this is load VO plus minus. Now we can see here, we can apply here the KVL again. KVL we apply here, so we will get the equation rise in voltage plus Vs, rise in inductive voltage will be plus VL, and drop in the voltage output will be minus VO. So we will get here VL is equal to VO minus Vs. This is the second equation. So now we know that according to the energy conservation law is whatever the energy is stored is equal to energy is released. So on time whatever the energy, that is equal to off time of energy, or we can say energy store is equal to energy release. So we know that the equation will be power on time into T on is equal to power off time into T off. So we know that the power is equal to voltage into current, so we can write VL into delta I, because on time also average current delta I and off time also average current delta I. So delta I into T on is equal to VL into delta I into T off. Now we put the equations of VL value from 1 and 2 in these equations. So we will get here first equation Vs into delta I into T on is equal to VO minus Vs into delta I into T off. Now delta I will cancel, so we can write here equation. We just simplify the equation, so we can write here Vs T on, this is negative T off, so it will go here common, T off is equal to VO T off, and this complete time period is T on plus T off, so we can write Vs into T is equal to VO into T off, and we can write Vs into T is equal to VO T off, we can write T minus T on, so we can write here T minus T on. So VO is equal to, we can write here expression of output voltage, we can write here is equal to Vs into T upon T minus T on. So now we divide T in numerator and denominator, we will get the equation new Vs into 1 upon 1 minus T on by T, and we know that T on by T is nothing but the duty cycle, so we can write expression VO is equal to Vs 1 upon 1 minus delta, and delta is the duty cycle. So this is the equation we are getting in the boost converter. So when delta is equal to 0, VO is equal to Vs. As delta is increases, so VO will be more than the, as delta is increases, so we will get VO is more than the Vs. So this is all about the boost converter. Thank you very much.